So we're now going to take a look at the concurrent map collector, and this goes along with the EX37 example that's going to create a map that contains all the words in Shakespeare and the number of times they occur, all the unique words in Shakespeare and the number of times each word appears, and prints things out in various orders. And the way this works under the hood for the concurrent collectors is it uses this thing called a concurrent map collector. And this is a nice collector that goes above and beyond what you get out of the box with Java, because Java will make you some concurrent collectors in the collectors utility class. However, the concurrent collectors that Java creates for you out of the box are never sorted. So you don't have, say, a tree map where the keys will be sorted in either ascending or descending order. So we're going to remedy that gap by creating our own concurrent map collector. And you can see it takes a bunch of parameters. It takes T, which is the type of elements in the stream, K, which is the type of the keys, V, which is the type of the values, M, which is basically a merge function, and, or sorry, M is a map that we're going to return as the result from this. So you can get back a tree set, a tree map, for example. And then we're going to implement collector, which we pass in T, map of KV, and then M. So in order to make this work properly, we have to have these various functions that take the elements in the stream, which in our example, for instance, would be these works of Shakespeare that we're dealing with that we've turned into these map entries. And we're going to convert them into either keys or values. And then we also have a merge function. You see how this stuff gets used. And there's also a map supplier. So these are all fields that are defined in the private portion of the collector. Here's the constructor. Sorry, this is not the constructor. Well, this is the factory method that makes us a new instance of concurrent map collector. And you can see it makes a concurrent map collector, passing in all the parameters that are passed in here from the call. And if you were to go back and take a close look at how this is used in the program, you would see it passes in all the various elements that it needs here. So let's go back over here and see if we can find that. So here's the toMap method that's being called. It's going to pass in this case, function identity, which is going to be just the word in the list of, or the stream of Shakespeare words, an initial count of 0, basically a merge function, and then the constructor reference to make the appropriate type of collection that we want. So that's where it gets called. That's what this is going to do. It's going to make a map collector that does these things. Here's the constructor. It just sets the fields. The supplier here is going to make a new concurrent hash map. So it passes back a constructor reference to a concurrent hash map supplier that makes a concurrent hash map when its get method is called. That's done, of course, internally by the collector framework. Here's the accumulator. You can see it takes whatever type of map we've got, and it calls merge, applying the key mapper on the element and the value mapper on the element to get the keys and the values, and it also applies the merge function. And then the combiner, as you can see here, is going to basically merge the two maps together. It's going to put all the elements in the second map into the first map and return the first map. And then here's the finisher. This finisher is very similar to the finisher we saw before for concurrent set collector, but in this case, we're going to have a map, not a set, and we get the map by calling mmapSupplier.get, which returns the new map, and it then goes ahead and gets a check to see whether or not this is indeed a concurrent hash map that we're asked to return the results as. If we are, we just give back the map because we've already collected into it, and we don't care about ordering. But in a more interesting use case, if it needs to be a different type of map, like a tree map, then we go ahead and add all the elements of the concurrent hash map into the new map, the new tree map, for example, and return the new map. And then there's just the characteristics that says this is concurrent, and it's also unordered. So yet another interesting example of how you can make your own custom collectors. This one is really quite powerful and efficient. And as we saw in the earlier video when we took a look at the run times of this stuff, under the right circumstances, it can be very efficient, especially as the number of elements gets large. So you can see here, for example, that the concurrent tree map is a little faster than the non-concurrent tree map collector. And that's because it's able to use the concurrent hash map internally to avoid having to pay the overhead of merging things together. However, you could also see that for hash maps, the non-concurrent hash map was actually more efficient, indicating that it's more efficient to merge hash maps that are non-concurrent than it is to do a single concurrent mutable result container.